In the world of quantum computing, Classiq is revolutionizing how quantum software is developed. This short video describes both the problems and the solutions for quantum algorithm design. Quantum computing is going mainstream, and many organizations are building their quantum teams. Indeed, Gartner predicts that by 2023, 20% of organizations will be budgeting for quantum computing projects. But quantum software development is still in its infancy. Today, quantum circuits are laboriously developed at the gate level. Quantum teams have to rely on highly skilled quantum information scientists, and those are hard to find. But even these PhD-level scientists are limited to gate-level design or to tweaking pre-written building blocks. The current way of developing quantum software is simply not scalable. Quantum computers are becoming more powerful every year, but gate-level programming is making it impossible to design, debug, and maintain new algorithms and larger circuits. Additionally, companies find that gate-level programming makes it exceptionally difficult to integrate subject matter experts, such as experts in finance, chemistry, or supply chain, into quantum teams. Classiq solved this problem. For inspiration, we looked at the design process for electronic circuits. Many years ago, simple circuits were designed by tying together logic gates such as AND, OR, and NOT. But as circuits became more complex, it was clear that gate-level design is not a scalable solution. This led to the introduction of VHDL and other high-level modeling languages. With VHDL, engineers could specify the desired behavior of electronic circuits and then have computer software synthesize an electronic circuit that behaved as desired. Classiq uses a similar approach for quantum circuits. With Classiq, quantum software engineers start with a high-level model of the desired behavior of the quantum circuits. Additionally, they define the constraints, whether they wish to fit into a certain number of qubits, require a particular level of accuracy, have limitations of the length of the circuit, and so forth. Classiq automatically synthesizes a gate-level model that meets these constraints and then provides the low-level code that implements it. With Classiq, designers can focus on creating new quantum algorithms instead of laboring to translate them into interconnected quantum gates. The ability to meet designer constraints is particularly important at this time. Different quantum computers offer a different number of qubits, different levels of stability and qubit interconnection, so it's very important to optimize the desired algorithm into the given hardware. Classiq analyzes numerous options to find the best one that meets the given constraints while delivering the desired behavior. When you want to use different hardware, there's no need to recode or revise the high-level description. Just update the constraints, and the Classiq platform will do the rest. Classiq not only synthesizes quantum circuits, but also helps analyze and visualize them, making it easier to debug and maintain complex algorithms. With such analysis, a new designer will find it much easier to understand the work of his predecessors and to make improvements as required. Recapping, the Classiq platform has three parts: high-level modeling that allows teams to design at a high level, not the gate level, while specifying the constraints that matter to them; circuit generation that automatically synthesizes the optimal circuit and performs hardware-specific optimization; and circuit analysis and debug that makes circuits easier to explain, understand, revise, and reuse. Why is this important to customers? With Classiq, quantum software teams can design circuits that were simply impossible to design using the older methods. Teams dramatically speed up the design process and find that integrating subject matter experts is becoming much easier. Indeed, customers are using Classiq in a variety of ways, from option pricing and finance applications to chemistry and drug discovery to defense applications. Classiq allows them to create both pure quantum algorithms as well as hybrid Classiq quantum ones, and allows them to start delivering on the big promise of quantum computing. Are you ready to break through the current limitations of quantum algorithm design and experience a revolutionary way to model, synthesize, and analyze quantum circuits? If so, we'd love to hear from you.